So, open-ended, interrupt me, ask questions. We'll just kind of demo various things. But there's one bit of kind of prerequisite discussion that we need to do. Which is, as you're using a tool, it's normal to kind of build a mental model of the tool. And I think a lot of times people build up a mental model of Git, which is different than how it works under the covers. Like I never really appreciated Git. I thought it was verbose and complicated, and I didn't like it at all, and resisted it for quite a long time until I read a book that kind of laid bare the mental model of, or how Git works under the covers, and so I was able to adjust my mental model. And after that, I loved it. I thought it was a really great tool. So if this is review, sorry in advance. Otherwise, let's get into it. So I think oftentimes it's tempting to think of branches as kind of an entity, something with purpose, something, a branch is a noun, it's a thing. We can refer to it, and in Git, that's very much not the case. So Git, as you guys know, is a directed acyclic graph, a DAG. That's how it models everything internally. And I think visualizing Git as a DAG is really, really useful when talking about Git internals. Because it kind of breaks down the notion that a branch is something special. So a branch in Git is a pointer. And if you've ever heard that said, but don't know what that means, it is very literally a pointer. So Git, not head, let's do refs, heads master. So a branch in Git is this file, this text file that lives inside of your Git directory. And the only time that's not the case is if your refs have been packed. Now usually usually branch names are not packed, but if this file exists, then it's the exact same idea, but just in a single text file instead of a bunch of files that are scattered across a few directories, just for performance reasons. Now Git will pack refs if you've got a lot of them for performance reasons, or if they're the kind of refs that are not updated or accessed very frequently. But by and large, a ref, a branch in Git is just a pointer. So it's this text file with a SHA, and that's it, right? So we can do a git show. Oops, I didn't quite catch that. And that's just a commit. We just got started, so you haven't missed anything yet. So that's what I mean when I say a branch is a pointer. It's just a text file. Which means it's about as ephemeral as it gets. As soon as that text file is gone, then all records of that branch are gone. And so when I say a pointer, that's saying this is currently the master branch. Right? This is refs, heads, master. And so it's just pointing to some arbitrary place in the graph, in the DAG here. So if we were to manually change that text file and say, actually, this is the master branch, Git would be completely fine with that. That's not a problem.
So sorry, what does each node represent?
Each one of these are commits.
Okay.
Yeah, thanks. I should have spelled that out. So when you do a merge, say you've got a branch over here and a branch over here, and you do a merge, it creates a new commit with two parents. And so this is now a merge commit. And oftentimes, you're not going to have a branch, or you're not going to have an internal Git graph that goes off in all directions. Sometimes you do, and sometimes there's good reasons for that. If you've ever played around with GitHub Pages, and they make that weird kind of GH sites branch, I forget what the branch name is called, but GH Pages branch. What that does is that just adds a completely disconnected node in your DAG, and then starts branching from there. So oftentimes, as you make commits, they're going to look kind of linear. You're going to have the occasional merge, right? Maybe you've merged that into here. And so there's going to be a little bit of branching, but for the most part, it's going to look linear. And that's why when you look at the graph using, say, gitlog -- graph, that linear view, that kind of default linear view, it looks all right. It tends to work out. But I think that implicit in that is the kind of temptation to think of Git's graph as a linear thing, when it doesn't necessarily have to be. In the case of something like this, where it's a completely disconnected thing, or in the case of long-running branches that are not connected, you never merge those branches for whatever reason. And so as a mental model, I really recommend thinking about the DAG as a completely separate thing. So, that said, when you do a git pull or a git fetch, what you're doing is you're calling out to some remote repository which has this exact same graph somewhere else, but maybe a few more nodes, and you're saying, which nodes don't I have in my graph? And so when you do a git fetch, it just grabs all of those nodes, puts them in your copy of the graph, and so there you have all of those nodes locally now. So when we're talking about remotes in Git, that's kind of a misnomer, because a remote in Git is still a local reference. So if you do a git fetch, and one of your coworkers has some long-running branch here, this ref right here, it's going to be refs, remotes, and then some name, the remote name, origin. Running into myself. Origin, branch name. But it's still a local ref. It just came from a remote. So you can merge this into your branch if you know how to specify the address. Any questions about thinking about Git like this before we move on?
When you say you can specify a commit as the master, what does that? Does the commit itself? Does the one node include all the code for everything?
It's a good question.
Is that a deeper question than you want to?
It can be. The short answer is no. Each commit object is comprised of multiple other kinds of objects in Git. A tree object, and each tree object is comprised of what are they called? Blob objects. So if I were to say have a text file, and I were to copy that text file and put it into two different directories in Git, then what you'd have, and then commit it, what you'd have is you'd have a commit object that refers to a tree object saying, foo lives here, and then foo has a reference to the actual blob object, which is the contents. And then if I had another one, it said it's actually bar/foo, but that refers to the same contents. Git doesn't duplicate the content. And then Git will occasionally recompute diffs. So as you change this over time, move it around or just change the contents of it, Git will compute diffs of it little by little as it goes. So that's a longer discussion, but that's kind of a very short. Okay. Let's see. Okay. So and then one other thing, and I'll harp on this quite a bit as we go today. But when you delete a branch, or when you cherry pick, or when you rebase, you the end user, never, ever, ever remove anything from this graph. It never happens. You, the end user, don't do it. Git will do it eventually, and we'll talk about the ref log as we go. But you never remove anything from this graph. So the takeaway from that is if something is in this graph, meaning if you've committed something, it's in there somewhere, and you can find it if you lose it. So say like you do say, this is my master branch, but I'm going to do something crazy, and I'm going to manually update my master branch to point to this. You can always find this again if you lose it. It's in there. Now Git will delete it eventually, and we'll talk about that when we talk about the ref log. But you can't lose things. Once they're in a commit, it's safe. You can get back to where you were. So rebasing can be kind of scary, especially if you lose your place or you end up in a weird spot. But you can get back to where you were. So let's do it. So I'm going to make a Git repository. And let's start with what a merge looks like with this kind of graph idea in mind. So I've got a Git alias called stub. And basically what this does is this just does a git add and a git commit in kind of a deterministic way. I do demos often enough that I find this is a nice shorthand. Just keep in mind, stub isn't doing anything magic. It's just touching a file, adding a file, and committing a file. That's it. So if I do git stub a, there we've got a file named a, and this is what our Git history looks like. So added a. Right? So now I'm going to do a git stub b and c. So this is what our Git history looks like. Added a, b, and c. So at this point, you or one of your coworkers goes and makes a branch. Git checkout branch, my feature branch. And we're going to make this branch off of the current commit. So we could specify head, but that's redundant. So we're going to make the feature branch. In our graph, we're going to, so we've got added A, added B, added C. We're going to branch from here. So now we're on a new branch. So things to watch out for as we go is I've got git information in my prompt, so you can see what SHA we're currently on, and you can see what branch we're currently on. So keep an eye out for that as we go.
Sorry, what's a SHA?
A SHA is...
Is that the little...
The numbers on the right.
Yeah, this one over here on the right. So if I do, so when I did git log, for example, this 9134A corresponds to 9134A. So it's just a unique SHA-256 hash of that commit. And I'll kind of, I'm glad you asked, because I'll kind of stumble around and refer to SHAs or refs or branches kind of interchangeably, because as far as Git's concerned, they're almost the same thing. Certainly refs. Ref can be a branch or a SHA or whatever else. All right, so right now, if I do a git log on my feature branch, you can see that that nothing's changed. And so let me draw what I've done. And for those that are remote, this is not going to be visible. Sorry, I'll show the the actual bag here in just a minute. So say like we've got A, B, and C commits, A, B, and C, right? And these, it's a directed graph, so these are going in one direction. So now we've created a new branch, right? The only thing we've done by creating a new branch, the only thing git checkout -b branch or git branch, new branch name, does is right now we've got a pointer to this as the master branch. The only thing we've done, literally the only thing we've done, is we've made another pointer to the same commit called feature. That's it. There's no difference in the graph. And you can see that reflected in the SHA. They're referring to the same SHA. So let's look at what that looks like from Git's perspective. And I think I'll stop whiteboarding, so those who are remote should be able to pick things up from here. The way we're going to do this is I'm going to do git graph dag. This is a little shell script that I have to take output from Git and generate a graph fizz graph. And that's it. That's all it's doing. So I'm going to tell it to start from head. And here we've got our commits. So this is almost exactly what we were looking at with the git log. Added A, added B, added C, and we've got 3 refs that refer to this top one: head, my feature branch, and master. They all refer to the same commit. Okay? So now, if I do a git stub, what are we on, D? Now, if I generate that graph again, we've got this slightly modified version of the DAG. So now my feature branch is branched off of master. Now we've got a change to the DAG. So let's do stub E. Okay, so while we've been doing all of this work on our feature branch, looks like that now, somebody has merged their feature branch back into master. So pardon the digression here, but I'm going to jump back to the master branch, and I'm going to, let's see, what did we do? D? So somebody's merged their feature branch into master. So now we've got additional commits on master. So if we jump back to our feature branch, now they've diverged. So this is one of those things where it's great to have the upstream tracking branch set and displayed in your prompt. So right now I don't have it set. So I'm going to do that. I'm going to do a git branch set upstream to. Now usually this is going to look something like origin master, right? Or origin my feature branch. But one of the interesting things about an upstream tracking branch is we've already talked about how if a branch is quote unquote remote, it doesn't mean anything. Those commits are still available locally. So you can set your upstream tracking branch to anything you want. So I'm just going to set my upstream tracking branch to master. So if I didn't have a master branch, or if I was tracking some remote like origin, the results would be identical. I hope that's not too confusing. But now you can see I'm 2 commits ahead and 2 commits behind. And if I do git status, it's that same information. Okay? You have 2 and 2 different commits each, respectively. Use git pull to merge the remote branch into yours. So this is finally where we come to a place where we want to either merge or rebase. So let's visualize that. Git graph tag, and so I'm going to have this show us the master branch and my feature branch. And so that's what the graph looks like at this point. Any questions? Hopefully add E first and add E are clear. My intent by naming those commits the same is just to communicate that they're at the same level in the graph. They're completely different changes, but they're at the same level in the graph. All right. So now if we merge, git merge, we could locally update our master branch. Say those commits were available on GitLab and we hadn't pulled them down. We could do a fetch to pull them down. We could update our local master branch and we could merge our local master branch. We could also just merge the remote branch directly. So we could do origin master. That'd be just fine, assuming we had an origin. So again, think of remotes as just kind of a misnomer. They're local commits in your DAG. So I'm gonna git merge master, Okay, write a commit, and now that's done. So now, if I generate the graph again, of course, these two branches have now converged into a single commit, and there's an awful lot of refs that point to that one commit. So pretty straightforward, right? Any questions in regard to the graph view of this, though, before we continue? Mm-hmm.
You did get merge master, which is referring to your local master bridge, but if your local master bridge wasn't up to date to origin master,
then yeah, that wouldn't have worked. You're exactly right. And that's one of the reasons that I often don't merge my local master branch, because in order to merge my local master branch, I have to check it out. I have to, do a fast forward merge, and I have to keep my local master branch up to date when, generally speaking, I'm not doing work on that branch. I don't care about that branch. So oftentimes I will do a git merge, no fast forward, and we can talk about fast forward merges in a bit, origin master. So if I've done a fetch before I do this, I know without any ambiguity that origin master refers to the latest commit on the master branch that exists on GitLab. And so that way I don't have to worry about my local branch. I can just worry about this. And again, it's a local ref because I fetched, but now I don't have to worry about this trash master branch instead. In fact, oftentimes I'll delete my local master branch. On the same token, when I create a new branch, some new branch, I'll often specify that I want the starting place for that new branch to be origin master. So again, I know that I'm starting from whatever is the latest on GitLab, and I don't have to worry about keeping my local thing up to date. All right, so let's undo this. I'm going to keep this picture up, and I'll refer back to it. So what I'm going to do is I am currently on my feature branch. So I'm going to undo this commit. I'm going to do a git reset -- hard. I'm going to go up one commit. And as you can see, that put me back where we started before the merge. So if I do a git graph dag, we're back to this, right? We've already seen these two pictures. So the only thing I did when I did that reset, the only thing I did was update the pointer. That's it, of my feature branch. So yeah, is that clear to everybody? Git reset -- hard says change the my feature branch pointer from this commit, A57 whatever, back to FAC. And that's the only thing that happened. But you can see that this commit doesn't show up in this graph on the left anymore. But it's still in there. It's still in the Git database. And that's one of the biggest takeaways when it comes to rebasing and just kind of feeling confident with Git is I did something destructive. But the thing that I did that was destructive was I overwrote a pointer. The changes, the code that I actually care about, it's still in the DAG. Git hasn't removed that for me, not yet anyway. So Git will keep that around for 90 days. And I've had instances where, like 2 months later, I've remembered, hey, wait a minute, I already solved this problem, but I didn't commit it. I wonder if I still have it. And I've gone looking, and it's been in there, and I've been able to resurrect changes just because they've been inside of my DAG. So any questions about reset?
Reset hard versus reset soft. What's the difference? Is it soft just returns the changes?
Generally speaking, it's going to do different things in terms of which pointer it updates, whether or not it updates the working directory or not. I actually don't remember off the top of my head. I think soft keeps the local, the working directory intact, whereas hard will nuke it. Oh, there it is. Let's say does not touch the index file or the working tree at all, but resets the head to commit. So it changes that head pointer to commit. Mixed resets the index, but not the working tree. Okay, so this is the default one, if I remember right. So this is, with this one, it keeps any changes you have in the working tree intact, but still messes around with the index. And then hard is, it just obliterates everything in the index and the working tree. So if you've got like uncommitted changes and you do a hard reset, you'll lose them. But if they're committed, you can get them back. So let me show that. So don't take my word for it. I said this commit was still around. Let me show you that I'm not making stuff up. So one of the reasons I like to have the git SHA show up in my terminal here is when I'm doing stuff like this, I can just grab it out of the terminal without having to go looking for it. So now let's do a git graph DAG, and we're going to do those two branches again, but we're also going to specify this other commit. So let's see, how do we get all of those to surface? All right, so here's the three graphs that we're looking at so far. And they're identical, save for, with this last one, I've asked GraphViz to draw that top one for me with a dotted outline to communicate the fact that there are no refs that point to that commit anymore. And so it's still in there. We can still look at that commit and do things with it, but no refs point to it. And that's where Git will start to clean things up for you eventually. So Git has a garbage collection phase, and I'll bet you guys have seen it output stuff on the terminal every so often. And it also does things that it doesn't output to the terminal. But Git will hang on to this for at least 90 days with default settings. So we can always get back to this dotted commit in that 90 days. And if we need to go looking for it, we can do git ref log. Is that hyphenated? No. And we can see all of the changes that I've made to head. So it just kind of tracks as I move things around. Anytime I update a pointer, that shows up in the ref log here. And so we can find that commit in our ref log. So it's A57 right there. So it's in the ref log. Oftentimes with the ref log, I like to do date relative date. Yeah, and I've aliased that to just get ref log. But that helps me kind of see, 5 minutes ago versus 16 minutes ago versus 3 months ago. So that just kind of helps me navigate the ref log. But it's just like git log. You can output it in a variety of ways depending on what you're looking for. All right, so any questions about these three graphs? Okay. I will keep them up, and let's contrast with git rebase. So with rebase, what we're doing is instead of making a new node in the graph with two parents, like a merge commit would, with a git rebase, we're saying replay all of the commits on my branch on top of the latest commit on some arbitrary other place, right? Replay those commits, as in copy them. So by default, if I just run git rebase, that'll do what I want it to do because I have an upstream tracking branch. Rebase was written to work with upstream tracking branches so that you could rebase your changes on top of changes that have been made to, committed to GitLab, for example. You can also specify what commit you want to rebase on, and you can even get pretty tricky by rebasing onto various things. And I'll go into that if we have time. But so if I just run this without any arguments, it will apply my two commits on top of where we were. So let's graph that. Let's see. So let's keep this in place, and let's also grab the let's grab the commit before my rebase to see what that looks like. Actually, let me just show you what this looks like normally, and then we'll go back and do the extra stuff. Okay, so if I look at my master and my feature branch, the purpose of rebase is here's the master branch, and I've replayed add D and add E for my feature branch on top of it. So the whole purpose of rebase is to make this history look nice and clean and linear, right? It's like, I'll go into the philosophy behind why you might want that versus master in just a second. But yeah, all nice and linear. But then again, as we've discussed, all of those other refs are still there. So let's grab that one and that one from our merge. And they're all still in there as well. And so this is what the DAG actually looks like, right? This should look familiar. And there's that merge that we undid. So that's what my DAG actually looks like. That's what the Git database, if you want to think of it that way, actually looks like. But then since we rebased, we've got this nice linear history going up the left there. And it looks linear if we just look at it and get log. Any questions?
I'm noting that the add D and add E got a new SHA. Each of them got a new SHA.
Thank you for mentioning that. Yes, I was going to mention that. I completely forgot. So the SHA in a Git commit is comprised of a few things. It's comprised of the SHA of its direct parent or parents, if there's more than one. The author, the commit date, the author date. Let's see, the commit or the author, the commit date, the author date, and the two SHAs. And I forget if I'm forgetting something. In any case, it's comprised of a few bits of data. So if any one of those things changes, the SHA changes. So in this case, the parent's changed. So the parent was this 931, but since we rebased, the parent became this FAC. And so all of the SHAs changed. So we've replayed the commits, meaning we've duplicated the commits. And I mean that very precisely. We copied the commit. And like we already talked about, it didn't copy the contents of the file. Git just refers to one blob, way under the covers. But it did create brand new commits with pointers to different blobs and different parents. So is this helpful? Does this graph kind of visualize the difference between the merge approach and the rebase approach? Okay.
Actually, a question. For example, what if there are conflicted files between those two? Add E first, let's say. So that will just be prompts to solve all the conflicts, and it'll show the changes, and we'll have to make another commit on top of everything else. Right?
Yes. So I would like to do a session just about resolving merge conflicts. If you guys are interested in some future time. The reason is I'm very opinionated about how to resolve merge conflicts, and I feel like the discussion on resolving merge conflicts is one of those discussions that everybody kind of avoids, or everybody kind of doesn't know to address. And I think all of the kind of canonical ways to resolve merge conflicts are missing some fundamental ideas. So I'd love to talk about conflict resolution specifically one presentation. But to your point, when you do a merge and there's conflicts in these two commits, you resolve those conflicts, and the resolution of those conflicts, the actual changes, show up in the merge commit. And this is one of the times where Git show can be really, really helpful, whereas GitLab is not helpful. So like, if you ever do, like a process review, somebody's like, I just merged master and there were a couple of minor commits, and so I've updated my branch. Can you reapprove it? Right? Everybody here has done that at least a million times. So when you look at the changes that show up in GitLab, it's everything that came into the branch, right? It's everything that was in master that has now been introduced into this branch, which is 100% noise and 100% useless. You just want to know what the conflicts were and how the person who resolved the conflicts resolved the conflicts. So if you were to say, look at, let's see, 857, if you do a git show, and I don't remember, let's see, I enjoy these flags to git show so much that I've got an alias for it. So show me a summary of what changed, show me the diff stat, show me all of the files that were changed, show me a little bit more information than git show does by default, and show me the patch. And this patch thing is awesome. So if I were to do a git show and then that commit, so right now it's not showing me anything interesting because there were no conflicts. But say there had been conflicts, the diff of just what they changed shows up here, which is the one thing you want to see out of GitLab, and it doesn't surface there. So if anybody wants you to do a process review, do a git fetch so that you've got all of those changes locally, and then do a git show on their merge commit, and you'll see exactly what they changed. And then you'll feel a lot more confident when you do your process review, because you can say, I see you did these specific things, and those look good to me.
Or they don't fire.
Right. Yeah, or they don't, which is more common than I think a lot of people like to talk about, because doing conflict resolution can be really, really tricky. All right. So, yeah. So when you merge conflicts in a merge commit, those changes that you made actually show up in the merge commit itself. Now, the merge commit is a regular commit, just like anything else. Meaning you can put changes into there. And somebody had a really clever name for that. What was it? One of the, who was it? One of those kind of Twitter personalities in the tech community. And they called it, they called sneaking changes into a merge commit something funny, like, sneaking, you're backdooring changes. So just keep in mind that changes can show up in that commit, and oftentimes there's good reasons for it. Like sometimes when I'm reviewing a pull request in one of my Git repositories, one of my, on my own personal GitHub, and they've made most of the correct changes, but I disagree with the way they declared a variable or something like that, because it's style inconsistent with the style of the project, or minor nits, and I want to clean that up. I could say, yeah, this looks good to me. Can you just change this one little thing? And sometimes I do. And oftentimes that's just more trouble than it's worth. So it's like, hey, thanks for the change. I'll fix this tiny little nitpick. And so I'll merge their change, and then I'll change the thing that bothers me as part of that same merge commit. So you can put kind of unintended or changes that are not just in the merge in that as well. When you resolve commits as part of a rebase, those commits show up wherever you resolved them. So if the conflict was here, the conflict resolution lives here, or if it was here, it lives here. And the only person that knows that is you. That's not recorded anywhere. Which is a good segue to the philosophy behind why you would ever want to rebase and why you would ever want to merge. So the very brief, like the brief explanation, the takeaway is you rebase when you're the only person working on that branch, and you just want your commit history to read well, and you merge whenever anybody but you cares about that branch. And if you rebase when somebody else cares about a branch, pandemonium ensues, because you've pulled the rug out from under them by changing all of the shots. So they go to do a fetch, and they're like, well, this looks totally different, right? I can't meaningfully compare changes. I can't meaningfully merge. Well, you can, but it's troublesome. So whenever you do this rebase, because it changes all of the SHAs, it's going to confuse anybody that cares about my feature branch. If that person is only you, then the reason you would want to rebase is to make your commits linear, to read like a story. And maybe that's not important to you, and that's fine. Like, I don't think that there's anything wrong with always using a merge. Sometimes people like to complain about noise merge commits. Like if you're reviewing somebody's feature branch and every 3 commits it's merged master, merge master, merge master, it's like slightly annoying maybe, but but you can see how they put together the branch, very very mechanically. You can trace that history, and so that gets into when you would merge a commit in GitLab versus when you would squash a commit in GitLab. Squashing a commit in GitLab is always, in my opinion, a mistake because you're losing history. And the reason people like squash, the reason they would want to lose that history is because a lot of that history is noise. And so that would be a good use case for using rebase on your local branch. So like, this is my philosophy, and you don't have to follow my philosophy, but I'll lay it out, and you can feel free to disagree. When I make a merge request and I want somebody to review my merge request, it's my goal to make that review process as easy as possible, as smooth and as easy to figure out, because reviewing code is hard. It just is. Reading code in general is just kind of hard. There's a lot of abstraction and interaction and trying to decipher what these tiny little changes were that you made in this broader kind of code base that you understand because you've been in there for a week making these changes, but the person who's reviewing your code isn't as intimately familiar with this section of the code, and so it's hard. It's hard to review all of those. And so oftentimes I like my commits to read like a story. And oftentimes, if you've ever reviewed one of my merge requests, oftentimes I'll say at the top, this is best reviewed by commit. I don't always do that, but when I do, that's me trying to say, these commits should tell a story. It's like, in this commit, I had to fix this one little thing. In this one, I'm teeing up the big change. And then in this one, I make the big change. And so you can kind of see the mental progression of the addition. And so each commit is kind of its own standalone story. And oftentimes I'll make my commit messages quite long. And this is not something that's commonly practiced, but I think it's kind of nice to go back through the Git history of a particular file to say, why is this a thing? Like how did this come to be? Was this done on purpose? Was this done due to deadlines? Was this not done on purpose? And sometimes comments will tell that story, but not always. And so Git commits, that Git commit history is kind of another source of information. So if somebody's reviewing your commit and it reads linearly and it doesn't have all of the noise of merge master, because the person who's reviewing your commit, they don't care about your journey to get there. They care about the individual changes that are going to affect the code base from there on out. And so when I say my merge requests tell a story, it's not, I did a bunch of miscellaneous stuff, I resolved the conflict. They don't care about that. They just care about the high level of the merge request as a single kind of entity. That's the only thing they're considering when they review the merge request. And so that's the story I try to tell. So that's where I get all of those noise commits out there. When it comes to things like squashing, if oftentimes people that advocate for squashing are because it's common to do a bunch of noise commits. Maybe the team is just getting familiar with Git, and that's the easiest way to go. Or maybe people don't like constantly rebasing a branch over and over obsessively like I do, and that's not a value judgment, right? That's something wrong with my brain where I obsess over stupid minutia. So not a value judgment, that's fine. And then squashing gets rid of all of that noise and then just makes all of that noise into a single commit. The problem is not all of it was noise, and oftentimes with squashing, you then are left with this giant blob of changes, and you have to decipher that. And it changes the SHA because now you no longer have this SHA, this SHA, this SHA, you just have one SHA. So after you squash and you do a fetch, you can't just update your master branch because you can't just, you can't see that your feature branch was merged because all of the SHAs have been changed as part of the squash. So in my opinion, it's problematic just because it loses history. But again, there's an argument to be made on either side.
So there's a question. What do we do, for example, if it's a typo or something? Do you git commit, amend, no message, and just change your previous commit and push it back?
Yeah. If you want to get into my personal workflow, I rebase over and over and over and over. Wonder if I could showcase that. Let's see. How many branches that I've been working on? So yeah, so you can see oftentimes what I'll do is I'll make little commits as I go. So I'll be all like, you know, git commit, fix typo, git commit sort. Let's see, do I have any sorts? Got a bunch of work in progresses. Yeah, anyway, I'll do little things. Oh, here we go. I'll make a bunch of these kinds of things. I'll say git commit sort to this other commit when I have time to do so. You know, git work in progress, git work in progress, git work in progress, and then I'll rebase over and over with an interactive rebase, and we should go through that actually. We've got a couple minutes where I'll squish those together. I'll reorder them where they need to go, things like that. We could do that now. If anybody doesn't have any more questions about merging versus rebasing. Okay. So let's see.
I've never had a good experience with the rebase, so I'm really interested in this.
Nice.
Something always goes wrong.
The biggest reason why I don't like merge is just creates this ugly commit message, and instead of like, because in our previous company we had a great experience just organizing code and pushing the whole process was well polished, and so we had like a template for every commit message we had. For example, like use at the beginning 4 or 5 keywords like add, fix, remove, improve, and then just 3 to 4 words briefly explaining. Then commit, yeah, and so everything around that. So doing merge branch name, it just creates this ugly huge thing that's like you cannot read it right away. It's a single sentence. It's like this and that. So, and we always work, as you mentioned, rather one person, one feature, and very rarely that more than one person for a single feature. So rebase all the time.
Yeah, that's a great point. If you have processes in place at your work that require that you put certain emojis at the front of your commit message, or certain keywords to enable or disable continuous integration, that kind of a thing, rebase is definitely a friend there, because then you can just clean up all of that noise, and then you put that text just in the place where it needs to go. So let's go through like hopefully a fairly canonical session of sets coding. So say, we fixed the typo, history is actually spelled with 2 I's. And, let's see, we got this backward. The null is actually supposed to be first, so we're going to fix that. We brought in a totally new route. And oftentimes I won't commit as I go. I'll just do little things like this as I go. So I'll write it, and you can see Vim is telling me these things changed, these things are new. If you've never done git add-p, I highly recommend it because it says, do you want to commit these 2 changes? And you're like, well, actually, no, those are separate things, right? This one's fixing a typo, this one's doing something else, so I'll split that, and I'll say, yep, and then I'll quit out of there, and I'll do, fixed typo, which has a typo. And then, I'll commit the next thing, and so on and so forth. So that git add-p is nice for very incrementally staging very specific hunks. If your editor supports it, and it's worth looking into, because I think this is a pretty common thing. If your editor supports it, sometimes you can open your editor in a diff view, and you can then use that to stage. So you can say, I want to stage this, right? So now I'm going to make a commit message, which is fixed backward ternary. Sorry for my tiny screen. And then finally, the meat of the whole reason I came into this branch in the first place, I can commit that, which is add new route. Okay. So now, you can see I've got those commit messages. Oops, sorry, I was editing too fast in my tiny screen there. That's why that noise showed up. In any case, you can see my, my 3 commits there. So those are done, right? If I didn't make any mistakes, I'd be comfortable sending this as a merge request. It tells the story, right? The reason I came in here is to add a route, but I had to do these other kind of noise things as well. Maybe that's an argument that they should be separate pull requests, but that's another discussion. But I did it. I made a mistake. So we got to go back in there. And let's see. This isn't quite right. We also forgot to declare the history variable somewhere. So hash history equal to some value, right? That should have been in that first commit. I made some mistake when I added the new route because I forgot to swap out the components, other component. So this is shaping up to be kind of a realistic example of how I code day to day, which is completely scatterbrained, all over the place. And so we've got all of this crap, right? So that's what our diff looks like. We forgot to put those 2 things. So now I'm going to do a git add -p. Yep. And I'm going to make a commit called sort history value. And then I'll make another git add -p and sort fixed incorrect component. And I tend to make these somewhat descriptive some of the time, if it matters, because so here's where we stand. We've got 5 commits, and we really only need the 3. So now I'm going to do a git rebase -i. Now again, if I leave off where to rebase from, it's going to assume my upstream tracking branch, which is what I want at the moment. So you can see I'm 5 commits ahead of the upstream tracking branch. So if I do that without arguments, it'll drop me into the interactive rebase. So now I can start to fix these up. So sort history value, so I'm going to move that here, and I'm going to do a fix-up commit. So a fix-up commit discards the commits log message. So it just merges these 2 commits together and discards my sort, right? Fixed typo, that's good enough. That's fine. Fixed incorrect component, so this one is referring to this one right here. So for that one, I can do a fix-up as well, or I can do a squash. Let's do a squash. And in addition, I left this y in there by accident. That was a total accident. So I'm going to do r for reword. And if there's any commits here that are just noise, I can just delete the lines. And oftentimes, I don't want to make a rebase session too complex. And so usually I'll just do a few of these at a time. Maybe I'll reorder commits, make sure there's no conflicts, and then I'll merge the commits together, or whatever makes sense. So don't feel like you have to do everything in one rebase. So I'll save that out, and then it'll start going through the rebase process, and it'll start replaying those commits. It'll get to that first one, and this is the one where we squash those 2 together. And I just wanted to fix that one typo. So this was the squash where I just wanted to fix the one typo. So I fixed the typo, continue on. This is a combination of 2 commits. I added a new route. So I've got a little template that I use and I don't always fill out. And then we've got that sort fixed incorrect component. So add new route. And import new component, right? So I've combined those 2 messages. So now we're back to our 3 commits. So add new route and import new component, fix backward ternary, fix typo, right? Now it reads like a story, there's no noise, and that's now ready for a pull request. So that's kind of a pretty canonical rebase session for me. Questions about that? If it goes south, if I made some horrendous mistake when I did that and I accidentally merged 2 commits that were totally separate, all I need to do to get back to where I was is find that SHA. Git reset hard, and now I'm back to those 5 commits, and I can try my rebase again, right? I didn't lose anything. I could just try again and not, hopefully not screw it up this time. If the rebase is in progress and it goes south, you can always do git rebase abort, and that'll just bail you out and put you back to where you were.
So when I'm rebasing, I go through all the different commits, and I feel that I get to a point that where it should be. Then at the very end, I think that it succeeded, but then it says like my branch is like behind and it would get pulled. Is that, do you know what I'm talking about?
Yeah.
Is that normal?
Yeah, that can definitely happen. So, say I do a rebase and then I do a fetch. I doubt Robinhood has more commits right now. No, it does, but not on master. Say I had done a fetch and now I was behind commits. Then I just do another rebase. So if you're just behind commits, if the commits that are on your local branch look correct after you've cleaned them up and you're just behind, just do another rebase on top of the upstream tracking branch. So do a git rebase origin master, or again, that's default if you have an upstream tracking branch. So just do it again, right? Like maybe you ran rebase to clean up a few things and you had forgotten that you fetched 15 minutes ago, and now you did a rebase, and so it didn't pick those up for whatever reason. So yeah, that's a thing. And I wouldn't worry about it as long as your local the changes in your local branch look correct. And there's a large variety of ways to kind of figure that out. So like right now we're 5 commits ahead of upstream tracking. So if we do a git status, it's going to tell us that. If we do a git log one line decorate, which is what my git L is an alias for, we can say show me origin master ... and then my local branch. If I don't specify, it just defaults to head, which is what I want in this case. So that's going to show me the 5 commits that are outgoing. I even get obsessive to the point where I like to stage through individual commits, so I can do like git page out. Let's see. That's more than I want to go into right now. I've got Z shell aliases to just do this, right? Outgoing and incoming. But say I wanted to page through all of the outgoing commits. This just opens up each one of my commits in less. So there's commit number 1, there's commit number 2, there's commit number 3, there's commit number 4, there's commit number 5, and I can just step through them and say, yeah, that's what I wanted. Now I'm just going to rebase on top of, or maybe that's not what I wanted. Maybe I definitely made a mistake, and that's why it's complaining that you're still behind the upstream tracking. And if you don't have an upstream tracking branch, or if you rebase on something else, that also might be why it's complaining about that. But if it happens again and it's not obvious, just ping me, and I'll walk through it with you. Happy to.
Thanks.
Let's see. You can do git diff origin master head to see all of the changes that are outgoing. If you've also got changes that are incoming, that's probably not what you want. You probably want the triple dots. If you're not familiar with double dots versus triple dots, briefly, the mnemonic that I like to use for this, which is not completely accurate, but when I'm using double dots, the left-hand side is old and the right-hand side is new. So when I'm saying do a git log of all of my outgoing commits, this is all of the old commits, ... all of the new commits, and that shows me everything that's outgoing. If I did head ... origin master, that shows me all of the incoming commits. Whereas the triple dots are more like an exclusive OR. That almost always comes up with diff and very rarely comes up with log, but it's the exclusive OR. So with the triple dots, this says only show me a diff of the changes that I'm pushing out, and don't show me anything that's coming in or any other differences, just the changes that I'm pushing out. Might be a good place to end things. Feel free to hit me up on Slack if you ever have Git questions. I enjoy playing around with this stuff, and thanks for coming.
Thanks a lot. Also said, compromise yourself as an European spy right there. It's the clock.
Oh yeah, it's true. It's just a superior form of telling time.
Yeah, exactly.